In a box of 40 chocolates, 12 are made from white chocolate. What proportion of the chocolates are not made from white chocolate? Give your answer as a decimal.
So here we've got a box of 40 chocolates, of which 12 are made from white chocolate. The question asks us to find the proportion of chocolates that are not made from white chocolate. Well, if 12 chocolates are made from white chocolate, then of course 40 minus 12, which equals 28 of the chocolates, are not made from white chocolate. So we just need to find the proportion here. So we have 28 out of a total of 40. And we now just need to reduce this fraction as far as possible. We'll notice that both the top and the bottom are multiples of 4. So we can divide the top and the bottom of the fraction by 4, which will give us 7 over 10. Which of course equals 0.7, and that is our answer.
400 employees of the same company all claimed travel expenses. They each travelled 15 miles. Company expenses are paid at 30 pence per mile. How many pounds did this cost the company in total?
Okay, so we've got 400 employees. They each travel 15 miles. And they get paid 30 pence per mile. So we're going to do a simple multiplication. We've got 400 multiplied by 15 multiplied by 30. So if we do 400 by 15 first, we would get 5 times 4 is 20 with 2 zeros. We would get 1 times 4 is 4 with 1, 2, 3 zeros, so that's 1, 2, 3 and then 4. And we add those two together, so we get 6,000. Now we're going to do 6,000 multiplied by 30. Well, 6 threes are 18, but we've got 1, 2, 3, 4 zeros to carry over. Now I've got to remember this is our answer in pence, and the question asked us for an answer in pounds, so we just need to divide that by 100 to get 1800, or £1,800.
In a football squad of 25 players, 5 of the players are above the age of 30. What percentage of the squad is older than 30?
Okay, so we've got 25 football players, and we are told that 5 are above the age of 30. Now the question asks us to find out what percentage of the football players are older than 30 years old. Now in order to do this, we just need to find the proportion. So we have 5 out of a total of 25. Now what we need to do now is work out this in decimal form and convert it to a percentage. So what you could do is do 5 divided by 25 and times your answer by 100. But there is a slightly quicker way in this example. Notice how 4 times 25 is 100. So we can get the denominator to say 100. And we can do that by multiplying the top and the bottom by 4. And if we do that, on the top we're going to have 20, 5 times 4 is 20, and on the bottom we're going to have 100. And now you see we have 20 out of 100, and we can instantly read off that that is 20%.
There were 30 children in a class. 250 millilitres of apple juice was given to each child. How many 1 litre cartons of apple juice were needed?
Okay, so the key points to pick up from this question is that we have 30 children, and they each require 250 millilitres of juice. So we first need to calculate the total volume of juice, and we can do that by evaluating 30 multiplied by 250. So let's do this calculation here. We get 5 times 3 is 15 with 1, 2 zeros. We get 2 times 3 is 6 with 1, 2, 3 zeros. Adding these two together, we get 7,500 millilitres, which is of course 7.5 litres. Now the question asks how many 1 litre cartons do we need? Well, if we need 7.5 litres, we're going to need at least 8 cartons.
A family of 4 people wins £321 in a raffle. The family decides to share the money equally between each of the 4 family members. How much will each family member receive?
So in order to do this question, all we have to do is to calculate 321 divided by 4. Now there's a long way and a short way of doing this, but I'm going to jump into the long way first because that's what you would do in the general case. So we would write this as follows: 321 divided by 4. And we would say, well, how many 4s go into 321? That's not something I know off the top of my head, so what we can do is a little bit of long division. So we've got 321 and we have 4 here. So let's pick a really easy number of 4s that definitely go into there. Well, I know that 5 4s are 20, so 50 4s are obviously 200. So I'll make a note that that's 50 and this is 200. And we're going to take these away from each other. 121. Now I know that 3 4s are 12, so 30 4s must be 120. So let's do 30 from this and subtract these, and we're left with the 1. Adding these up, we get that this is 80, remainder 1. So, in here, we add in our decimal points. So we say how many 4s go into 321? Well, I now know that 80 do, remainder 1. So we put the 1 here. How many 4s go into 10? Well, 2. That's 8. And then we remainder 2. So how many 4s go into 20? 5 go exactly, so the answer is 80.25. Okay? But there is a slightly quicker way of doing this. What we could do is to recognise that dividing by 4 is the same as dividing by 2 twice. So 321, if we divide that by 2, well, the 320 is going to divide to 160, and the 1 is going to divide by 2 into 0.5. So that gives us 160.5, and we can divide this by 2 again. So 160 divided by 2 is 80, 0.5 divided by 2 is 0.25. So again, that gives us our answer.
2 students both attend a sponsored walk to raise money for charity. They each walk 24 miles and are sponsored at 24 pence per mile. How much do they raise in total? Give your answer in pounds and pence.
So in this question, we have 2 friends. They each travel 24 miles and they get sponsored at 24 pence per mile. So the calculation we need to do is 2 multiplied by 24 multiplied by 24, because that's 2 friends each travelling 24 miles and getting paid 24 pence for each mile they travel. Okay? So the way I'm going to do this, I'm going to first do 2 times 24, so that's going to give me 48, so we need to do 48 multiplied by 24. And I'm going to do that as follows. So 8 4s are 32, 4 4s are 16 with a 0, 2 8s are 16 with a 0, and 2 4s are 8 with 2 zeros. So we're going to add all this up, and we're going to get 1152. Now remember, this is in pence, so between them in total they earned 1,152 pence, which is of course £11.52, which is the answer.
What is 325 divided by 0.2?
Okay, so in this question we are asked to evaluate 325 divided by 0.2. Now the way we do this is, let's think about converting 0.2 into a fraction. Well, dividing by 0.2 is the same as dividing by 2 over 10, because 0.2 is 2 over 10. But if you remember, if you divide by a fraction, that's the same as multiplying by its reciprocal. And by that, I mean we flip the fraction, okay? So dividing by 2/10 is the same as multiplying by 10 over 2. So the calculation we actually need to do is 325 multiplied by 10 divided by 2. Well, 325 multiplied by 10 gives me 3250. And if we divide that by 2, well, the 3000 is going to give us a 1500, the 50 is going to give us a 25, and the 2 is obviously going to give us a 100. So when we add this all together, we get 1625, and that is the answer. These sorts of questions where we're dividing by a decimal are very, very common in the QTS tests. In fact, there are 2 decimals that I would just recommend that you learn and remember what they evaluate to, okay? And these are as follows. So if you're ever asked to divide by 0.1, it's worth remembering that that is exactly the same as multiplying by 10. Likewise, if you're ever asked to divide by 0.5, that is exactly the same as multiplying by 2. Now, of course, you can do the method we did in the previous page, and you will get exactly this result anyway.
A couple wish to buy £400 worth of dollars for their weekend in New York. At the current rate, you can buy $1.25 for £1. How many dollars will the couple receive for £400?
So we have £400, and we want to convert this into dollars using the exchange rate that £1 is equivalent to $1.25. Okay? So clearly the calculation we need to do is 400 multiplied by 1.25. And that's because if £1 is equal to $1.25, then £400 is equal to 400 times $1.25. Now we could do this in a grid, and that would take us a little while, but we would get there in time. However, there is a slightly quicker way of doing this. So notice that 0.25, that's a quarter, so we're timesing this by 1 1/4. So if we times something by 1.25, it's obviously increased by 25%, or increased by a quarter. Now a quarter of 400 is 100, and that's our increase. So we're just going to do 100 plus 400 is 500. So the answer should be $500.
An architect buys 21 pencils, each costing 12 pence. How much does it cost in total? Give your answer in pounds.
So in this question, all we need to calculate is 21 multiplied by 12, and that will give us the total cost of the pencils in pence. So we could do this in a grid. We'll get 21 multiplied by 12, 2 1s are 2, 2 2s are 4 with a 0, 1 1 is 1 with a 0, and 1 2 is 2 with 2 zeros. Adding this together, we get 252, but you have to remember that's in pence, so the answer is £2.52. Now if you wanted to avoid writing anything down here, you could just have a look at this. So we've got 12 times 21. Well, that's 12 times 20 plus another 1. So 12 times 2 is 24, so times 20 is 240, plus another 12 would give us 252. And then we would divide our answer by 100 to get £2.52.
A car dealership has 42 cars. If 28 of the cars are blue, what proportion of the cars are not blue? Give your answer as a decimal to 2 decimal places.
So we have 42 cars, of which 28 are blue. The question asks, what proportion of cars are not blue? And we need to give our answer as a decimal to 2 decimal places. Well, if 28 of the cars are blue, then 42 minus 28, which is 14, cars are not blue. So the proportion is going to be 14 out of a total of 42. And we need to simplify this fraction as far as possible. Well, we can divide the top and bottom by 2, and that will give us 7 over 21. And we can spot here that these are both multiples of 7. So we can divide the top and bottom by 7 to get 1 over 3. Now this is a fraction I recommend you learn off by heart. This, of course, is 0.333, and this recurs. So to 2 decimal places, this is 0.33. If you didn't remember that 1/3 is 0.33, you would of course have to evaluate 1 divided by 3, as follows. So we throw in our decimal points, and we say, how many 3's go into 1? Well, 0. So how many 3's go into 10? Well, I can get 3, because 3 3's are 9. And then I've left with 1 to carry over. And we do the same again, how many 3's in 10? You can see that this is just going to keep repeating forever and ever.
Workers in an office are either analysts or supervisors. There are 48 analysts in the office. If supervisors manage a team of exactly 6 analysts and any 2 supervisors do not manage the same analyst, how many people are there in the office in total?
So this question asks us to find the total number of workers in an office. We are told that the workers in the office are either analysts or supervisors. We are given that there are 48 analysts, and we are told that there are 6 analysts for every supervisor. So obviously the total number of people in the office is going to be the number of analysts plus the number of supervisors. We know the number of analysts, we don't know the number of supervisors, but that's quite easy to find because we know there are 6 analysts for every supervisor. In other words, if we take our number of analysts, 48, and we divide that by 6, that is going to give us 8. So we can see that we have 8 supervisors. So to answer the question, we just need to add 48 and 8 together, which is of course 56.
Sarah sends 15 text messages in 5 minutes. On average, how long does it take her to send one text message? Give your answer in seconds.
So here we are given that Sarah sends 15 texts in 5 minutes. And we are asked how long on average does it take her to send one text. Well, there are 2 ways of doing this. The first way is to say, look, if she sent 15 texts in 5 minutes, then she sends a text every 5 divided by 15, which is of course a third of a minute. So she sends a text every third of a minute. Now a third of a minute in seconds is of course a third times 60, which is 20 seconds. Now the other way we could do this is we could actually work out the number of seconds straight away. So we could say 5 minutes is exactly 300 seconds, and that is just 5 multiplied by 60. And then we would say she sent 15 texts in 300 seconds, so we're going to do 300 divided by 15, which is the same as 100 divided by 5, which is 20. Remember, if we divide something by 5, we multiply it by 2 and divide it by 10. So 100 multiplied by 2 is 200, divided by 10 is 20. So in this question we are given a scatter graph, and we are asked to find the proportion of the class that scored higher in algebra than calculus. Now you'll notice in this scatter graph, the y equals x line is drawn, this grey line here. And what that shows is that if there were any points on this line, that they got exactly the same mark in calculus as they did in algebra. For example, if I pick this point here, you could see that person would have got 40 in algebra and 40 in calculus. Now this is useful because it tells us that anything above the line has done better in calculus, and any of the dots below the line have done better in algebra. So we just need to count the amount of dots that are below the line, and we can see we have 1, 2, 3, 4, 5. So the calculation we need to do is we need to find the proportion, so we do 5 out of a total of 10, which equals 0.5, and that is the answer. Okay, so in this question we are asked to find which product generates the most revenue for the company throughout its lifetime. We are given a table, and in the table we are given 4 products. We are given their lifetime in days and the revenue they generate per day. So all we need to do is to find out the total amount of revenue for each of these 4 products and compare to see which is the largest. So all we're going to do is multiply the number of days by the revenue per day for each product. So for A, this is going to give us 100 multiplied by 20, which is going to give us 2,000. For B, we're going to get 70 multiplied by 25, which will give us 1,750. For C, we're going to get 30 multiplied by 30, which is 900. And for D, we're going to get 115 multiplied by 15, which is 1,725. From here, we can see that the largest number out of the 4 is the 2,000, which relates to product A, so the answer for this question is A. So in this question we are given a bar chart that represents the revenues of 2 companies over a 3-year period. And the question asks us to state which of the following statements are true. So let's go through them one by one. So let's look at statement A. And this says that the revenues of company A doubled from 2014 to 2015. So to do this, we're just going to have to read off the graph. So if we have a look at 2014, company A is of course the maroon colour, so we can see, reading off the graph, they had revenues of 30,000. Now in 2015, company A again had 60,000. So we've gone all the way from 30,000 to 60,000, and obviously 60,000 is 2 times 30,000. So the answer to part A is definitely true. Okay, let's have a look at statement B. The revenues of company B saw an increase of 50% from 2014 to 2015. Well, in 2014, company B had £40,000 worth of revenue, and in 2015, company B had £70,000 of revenue. So we can see that we've gone from 40,000 all the way to 70,000. Now, if the revenues did increase by 50%, we would expect that the revenues were 40,000 multiplied by 1.5, which is 60,000. Now remember that to increase a number by 50%, we multiply it by 1.5. So if there were a 50% increase, we would expect the revenues in 2015 to be 60,000, but they're not, they are 70,000. So we know from this part of the question that part B is false. Finally, let's have a look at part C. So this says there was a £20,000 difference in the revenues between the 2 companies in 2015. Well, we can see company A had £60,000 worth of revenue and company B had £70,000 worth of revenue. Of course, the difference between these 2 numbers is 10,000. So the answer to that is false. So the answer to this question should be A. So in this question we are given a table that illustrates the number of workers suffering with work-related stress in an organisation. The question asks us what percentage of the workers across all 4 departments suffer from work-related stress. Now the proportion of workers suffering from work-related stress is going to be the total number of people suffering from stress divided by the total number of workers. So we just need to find the total number of people suffering from work-related stress and the total number of workers. Well, to start with, we can find the total number of workers just by summing up all the values in this column. So we're going to have 12 plus 25 plus 14 plus 51, which is 102. So we have 102 workers in total. Now we can find the total number of people suffering from stress by adding up all the values in the third column. So we're going to have 3 plus 3 plus 2 plus 10, which is 18. So our proportion is 18 out of 102, and if we do 18 divided by 102 in our calculator, we will get 0.17647058 ... which is of course 17.647058%. But we have to remember the question is asking us to give our answer to 1 decimal place. So we round this to 1 decimal place to get 17.6%, and that is the answer. So in this question we are given a frequency table and we are asked to find the mean amount of time spent on the question. So the mean amount of time spent on the question is obviously the total number of minutes, so the total time taken divided by the total number of people. So we need to find the total number of minutes and the total number of people. Now we are given that the total number of people is 50 in the question, but we could easily find this anyway just by summing up all the values in the frequency column. So how do we find the total number of minutes? Well, this is a frequency table, so we can't just add up all the items in the first column. But we can think of it as follows. If 18 people spent 1 minute, then we have a total of 1 times 18, which equals 18 minutes for this first row. And in the next row, if we had that 27 people spent 2 minutes, then we have 2 times 27 equals 54 minutes there in total. And if we look at the last row, if 5 people spent 3 minutes, then we have a total of 3 times 5, which equals 15 minutes there. So we can add these three numbers together, and we would get 87. So in total we have 87 minutes. So of course, the mean is going to be 87 divided by 50, which will give us 1.74. But that's 1.74 minutes, and the question asks for our answer in seconds. So what we need to do is multiply this by 60. So 1.74 minutes is the same as 1.74 times by 60 seconds, which equals 104.4 seconds. Now, since the question asks for a whole number of seconds, we're just going to round this down to 104. So the answer should be 104 seconds. So in this question we are given a scatter graph that compares the number of driving lessons that a student has had against the number of minors they got when they sat their test. So let's look at the first statement. That says that 3/10 of the students had less than 9 lessons. Well, if the student has had less than 9 lessons, then they have to have had 8 or less. So if you look, we can see on the horizontal axis here we have the number of lessons. So we're looking for anything of 8 or less. So we have a dot here, here, and here. So we can see that we've got 3 people in total had less than 8 lessons. But that's out of a total of how many? Well, to find out the total, we just need to count all the dots. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So for part A, 3 out of 11 of the students actually had less than 9 lessons, which isn't 3/10, so that A is false. Okay, let's have a look at part B. So part B says the highest number of minors a student got was 10. Well, if we look on the vertical axis here, we can see that this gives us the number of minors. So we're just looking for the dot that's the highest. So if we go all the way up, we can see the highest dot here is this one, and that corresponds to 10 minors. So this part is true. Now the last part says the median number of lessons had 1 minor. So we need to find the median number of lessons. Well, the median is always given by the formula n plus 1 divided by 2th number. Okay? Where n is the number of dots or the number of people. So in our example, n is 11. So we're looking for the 11 plus 1 divided by 2, which is 12/2. So we're looking for the 6th number. Now notice that lessons is on the horizontal axis. So we need to count the 6th number along in order horizontally, i.e. from left to right. So starting from the smallest one on the left, we can see that this is 6 here. The next smallest on the left is 7. The next is 8. And then we have 2 at 9. So we have 1, 2, 3, 4, 5. And then the 6th one is here. So the median number of lessons we can see is 10, because that's the 6th dot if we count from left to right. But we need to know how many minors that person got. Well, if we draw along, we can see that that person got 1 minor. So the answer to part C is true. So the answer to this question is B and C. So in this question we are told that 2 separate samples, each containing 30 people, each tested 2 separate newly developed medical drugs. And we're given a table that compares the effectiveness level of each of these 2 drugs. And the question asks us which of the following statements are true. So let's jump right in at part A. So part A says that 1/6 of the patients taking drug A experienced high effectiveness. Well, we can see from the table, if we look for drug A, high effectiveness, we have 5. Okay? So that's 5 out of a total of 30, which of course reduces to 1/6. So the answer to that question is true. Now the other way of doing this is saying, well, there are 30 people in the sample, so 1/6 of the sample would be 30 divided by 1/6, which is 5. So if 1/6 of the sample experienced high effectiveness, then that equates to 5 people, and then we can read off from the table that there are 5 people. So let's have a look at part B. Part B says that the majority of patients in the sample for drug B experienced low effectiveness. Well, we can see for drug B low effectiveness we only had 7 people there, whereas in medium and high we had much higher numbers, so this question is obviously false. And finally, let's have a look at part C. So part C says that 1/4 of the total patients across both samples experienced low effectiveness. Well, across both samples we have 30 plus 30, which is 60 people. And 1/4 of 60 is 15. So if 1/4 of the total patients across both samples experienced low effectiveness, we would expect that 15 people experienced low effectiveness. But we can see that 5 people for drug A experienced low effectiveness, and 7 people for drug B experienced low effectiveness. And 5 plus 7 is 12, which does not equal 15, so we know that C is false. Again, we could approach this question in a similar way to part A, and we could say, look, well, we have 12 people out of a total of 60, which does not equal 1/4. So the answer for this question is A. Now in this question we are given a cumulative frequency diagram that represents the percentage scores of a spelling test sat by Year 7 pupils. And the question asks us which of the following statements are true. So let's have a look at part A first. So part A says that the median mark is 60. Well, with cumulative frequency diagrams, to find the median we first need to find out how many people there are in total. Now annoyingly the question does not tell us how many people there are in total, so we're going to have to use the graph. And the way we do that is we look for the highest point on the graph, and we can see that the graph is at its highest right here. And if we read off all the way to the left, we can see that the cumulative frequency here is 100. So we know that there are 100 pupils in total. And now what we do is we take this number 100 and we divide it by 2. Now 100 divided by 2 is 50. And then we go all the way down on the vertical axis until we hit 50. And then what we do is we simply draw all the way across until we intersect the line. And we can see that we intersect the line here. And this point here represents a mark of 60. So we can tell already that the median is 60. And that means that part A is true. So let's move on to part B. Well, part B is an easy one because part B says that the median mark is 30. Obviously this is false because we have shown in the previous part that the median is actually 60. So let's move on to part C. So part C says not one pupil got a score above 90. Now what we need to do is have a look at the graph around the 90 and above stage. Well, if we look here in this section of graph between 90 and 100, notice that it's flat. And that's very important because actually what this tells us is at 90 we have 100, a cumulative frequency of 100. So that means that 100 people got a mark of 90 or less. So 100 got 90 or less. But then if we go all the way to the end of the graph, which is obviously the maximum of 100 marks, we got that also 100 got 100 or less. So if 100 people got 100 or less, and the same 100 people also got 90 or less, then clearly no one got between 90 and 100. So the answer to this part is true. Now the easy way to spot this is just by noticing that the graph is flat here. And that means there is no growth, so there is no one who got above 90. So the answer to this question is A and C. So in this question we are given a chart that represents the revenues of 3 different companies over a 3-year period. And the question asks us, in which years did company B earn 1/3 of the total revenue of all 3 companies combined? So we have to be a little bit careful here. Notice how the question says years. So if we find 1, we're still going to have to check the other 2, because there may be more than 1 year where this happens. Now this question just boils down to finding a proportion. So company B is obviously illustrated by the light pink blocks on this chart. So let's have a look in 2014. Well, we can see the total height there is 90%. So total height is 90. And company B, we can see the width of that block, we go in between 90 and 60. So 90 minus 60 is 30. So the proportion is 30 out of 90, which is 1/3, which is great. So 2014 is definitely one of the years. Now let's have a look at 2015. So again, the total height is 60, but company B has between 60 and 50. 60 minus 50 gives them 10, so we have 10 out of 60, which is 1/6, which does not equal 1/3. And let's have a look at 2016. So the total height is 80, and company B has between 80 and 50, so company B has a height of 30. So we have 30 out of 80, which is 3/8, which does not equal 1/3. So there's only 1 year in which company B earns 1/3 of the total revenue, and that was in 2014. So that is our answer. So in this question we are given 2 pie charts that each represent the proportion of students in each class resitting algebra or trigonometry. And the question tells us that there are 25 people in class 1, and there are the same number of people resitting the trigonometry test in both classes. And it asks us how many students are there in class 2. Well, we know there are 25 people in class 1. And we know that there are the same number of people resitting the trigonometry test in both classes. Well, if we look at the pie chart here for class 1, we can see that 20% of the students in class 1 are resitting trigonometry. So let's find 20% of the 25 students in the class. So we can do 25 multiplied by 0.2, and that gives us 5. So this tells us that 5 people in class 1 are resitting trigonometry. But we are told that there are the same number of people resitting trig in both classes. So what we know is there are actually 5 people in class 2 who are also resitting trigonometry. But this isn't all the information we need, because if we have a look at this pie chart again for class 2, we know that 12.5% of the people in class 2 resit trigonometry. And we also know that 12.5% of the people in class 2 gives us 5. And if we find 12.5% of a number, we multiply it by 0.125. So 0.125 multiplied by the number of people in class 2 gives us 5. So to get the number of people in class 2, the calculation we need to do is 5 divided by 0.125, which gives us 40. So there are 40 people in class 2. So in this question we have box and whisker plots. and these represent the marks awarded for a piece of English coursework in 2 different classes in a school. So we can see that the maroon box is for Class A and the pink one is for Class B. And the question asks us which of the following statements are true. So let's have a look at part A first. Now this says the median in Class A is 30. Now the median is really easy to read off a box plot. It's always this middle number, this middle line here. So if we go to Class A and we pick the middle line, we draw all the way across, we can see that the median is exactly 30. So we know that A is true. Now let's have a look at part B. So the statement says that the highest mark was in Class B. Well, remember, with these type of diagrams, the highest mark is always this highest value here. So you can see the highest mark in Class A was 40, and the highest mark in Class B was 45. So of course, that is true. And finally, let's have a look at part C. This says the range of marks is bigger in Class A. Now the range is always the distance between the highest and the lowest value. So this distance here. So from here we've gone from 40 at the top to 20 at the bottom, so that's a range of 20. And with Class B, we've started at 45 at the top to 10 at the bottom, so that's a range of 35. So clearly the highest range was in Class B, so part C is false. Therefore the answer to this question should be A and B. So this question gives us a table that shows the percentage market share of 4 companies over a 4-year period. And the question asks us to identify which companies saw a continual decrease in their market share over the 4 years. So by continual decrease we mean that from year on year, each year it gets smaller and smaller, okay? So we just have to start with each company and work our way through. So let's start with company A. So in 2013 they had 18%. And this goes up to 20%, so these are not a contender. Now let's have a look at company B. So we start at 35, we go down to 33, down again to 32.9, and down once more to 31. So company B works because it's got smaller each year. Let's have a look at company C. So we start at 27, and we've gone up to 28.1, so that's not a contender. And then let's have a look at company D. We start at 25, we go down to 20, down to 16, and down to 12.8. So company D also saw a continual decrease. So the answer to this question is B and D. So in this question we are given a bar chart that shows the percentages of students in year 7, 8 and 9 who have had at least one detention this year. The question tells us that 36 out of the 144 students in year 9 have had at least one detention. And the question asks how high should the bar chart be for year 9? Give your answer as a percentage. Well, this question is actually relatively straightforward. It's another proportion question. So we're told that we have 36 out of 144 students in year 9 that have had at least one detention. Now if we type this into our calculator, 36 divided by 144, we get 0.25, which is of course 25%. So the answer to the question is 25. So in this question we are given a bar chart that compares the summer mathematics examination grades of 2 different classes in a school. And we can see that the grades are grouped as follows. We have A star to A, B to C, and D to F. Now the question asks which of the following statements are true. So let's have a look at part A. So statement A says that 10% of the students across both classes achieved A star to A grades. So what we need to do here is find out the total number of students. Annoyingly, we're not given it in the question. So the way we're going to have to do this is we're going to have to add up the heights of all of these bars. So we can see here we've got 5, here we've got 3, 15 here, 23 there, 20 and 14. So they're the heights of each of the bars, so we're going to have to add these together. So we're going to get 5 plus 3 plus 15 plus 23 plus 20 plus 14, and that equals 80. So we can see that we've got 80 pupils in total. And now we need to see how many people have A star to A grades. Well, we can see we have 5 in class 1 and 3 in class 2. Adding those together, we have 8. So we've got 80 people in total, and 8 people have A star to A grades. Now, 10% of 80 is 80 multiplied by 0.1, which is 8. So we can see that this is true, because 10% of 80 is 8, and we do have 8 people that have A star to A grades. So part A is true. Let's have a look at part B. So this says the same number of students in class 1 and class 2 attain D to F grades. Well, this one's quite straightforward. We can have a look at the D to F bars here, and we can see they're not the same height. We have 20 people in class 1, 14 in class 2, so we get that this is false. Finally, let's have a look at part C, and this says that there are 50% more students in class 1 who got grades D to F than there were students who got B to C grades. So if we look at class 1, we can see here that we have 15 people who got B to C and 20 people who got D to F. So we started with 15 and we've moved up to 20, and we need to know what that increase is. Well, let's assume there was a 50% increase. So we started with 15. Now if we increase a number by 50%, we multiply it by 1.5. And if we do that calculation, we get 22.5. So if there was a 50% increase, we would have 22.5, but we don't. We have 20. So we know that C is false. The other way we could do this is we could actually work out the percentage increase and see whether that does equal 50%. And the way we could do that, we could think, well, what if we multiplied 15 by to get 20? In other words, we could do 20 divided by 15, which gives us 1.3 recurring. So we can see that actually there's been a 33.3 recurring percentage increase, or it's increased by a third. So of course the answer to this question is A only. In this question we are given a table that specifies the Test 1 and Test 2 percentage marks of 2 pupils. We are given that Test 1 has a 40% weighting and Test 2 carries a 60% weighting. And the question asks us to identify the student that had the highest final mark. Now the final mark is given by this formula highlighted in blue here. So all we need to do is to apply this formula to pupil A and pupil B and see who had the highest mark. So let's start with pupil A. So we can see they had a Test 1 percentage mark of 80 and a Test 2 percentage mark of 75. So we apply the formula. We're going to have the Test 1 mark, 80, multiplied by 0.4, and we add on to that the Test 2 mark, 75, multiplied by 0.6. And this first bracket yields 32, and this second bracket yields 45. And when we add the two together, we got 77. So we can see that pupil A had a final mark of 77. Now what about pupil B? Well, pupil B had a Test 1 mark of 70 and a Test 2 mark of 82. So the calculation we are going to do here is 70 multiplied by 0.4, and we're going to add to that 82 multiplied by 0.6. And this first bracket yields 28, and this second bracket yields 49.2. And when we add these two together, we get 77.2. So we can see that pupil A had a final mark of 77, and pupil B had a final mark of 77.2. The question asks which student achieved the highest final mark, so we can see that this was pupil B, which is our answer. In this question we are given a table that compares the number of hours spent on revision by 7 students in the winter and summer terms. And the question asks us, what fraction of the students spent more hours revising in the summer term than in the winter? Well, we know what the total is. In total we have 7 students, so it's going to be something out of 7, a proportion. So all we need to do is go through each pupil one by one and see who spent more hours revising in the summer than they did in the winter. So let's start with pupil A. So we can see that they spent 10 hours in the winter, 15 hours in the summer. So they spent more hours in the summer. So we have that pupil A is a contender. When we have a look at student B, we can see that they spent exactly the same number of hours in the winter and summer. Now let's look at C. Well, we can see that they spent 3 hours in the winter and 7 hours in the summer. So of course we include student C. We do not include D, we do not include E, we include F, and we include G. So we can see that we have a total of 1, 2, 3, 4 people out of 7 who spent more hours revising in the summer than the winter. So our proportion is 4/7, and that is the answer.